another method of evaluating these integrals or antiderivatives. Guys, so far we learned the basic techniques using the rules. Then we also learned the method of substitution. We also looked at some shortcut methods, but now we have something more interesting and something more rigorous, and it is called the integrating by parts. So guys, this method is motivated by actually the product rule of derivatives. So I should make a note of that. It is motivated by the product rule of derivatives. So what I have decided here is that I'm not just going to write the integration by parts formula. There's a formula that you will see in the textbook. Rather, I would like to kind of derive this whole thing. And the other thing I want to do here is I want to give you my way of writing or evaluating integrals where we have to use integration by parts. Guys, if you look in most of the textbooks, you will find a formula which I'm not a big fan of that particular formula. So I like to write my own formula, which is not different than what you would usually see in the textbooks, but it is more like convenient, and it's more easier for me to use that particular formula and apply it to like actual problems. So guys, I'm going to verify it. I'm going to show you how we get it. Guys, try to follow these steps. If you do not follow all the steps, it's totally fine. At the end, I still want you to try to remember the formula or make a note of it or have it in your formula sheet, and then use it whenever we are trying to do things with when we have to use the integration by parts method. Okay, so guys, let me start by deriving this method. For this method, again, as I said, it is motivated by the product rule of derivatives. So for the product rule, we need to have the product of two functions, and that is what we actually have when we are trying to use the integration by parts. When you have a product of two different functions, or even sometimes product of two same functions, you may want to use integration by parts. Again, those things will be more clear when we actually start looking at examples. Okay, so right now let us say we have product of two functions u and v. Okay, so let's say we have product of two functions u and v, u times v. So guys, if I take the derivative of these functions, and I'm going to formally write that. So let's say I want to take the derivative of these functions with respect to x. Guys, we already know the product rule for derivatives. If you don't remember it, then go back and look at it, and then you can be able, we'll be able to move on from here. So the product rule says that the derivative of the product is first you write the u, and then there is the derivative of the second function, dv over dx, and then there's a plus. What do I have? I have du over dx, and then I have times the second function, right? That is what the product rule for derivatives is, right? Nothing crazy so far. So now, since we are interested in actually finding the integration by parts formula, so what I'm going to do from here is I'm going to integrate both sides, and we are allowed to, because we are going to do it both sides, not just one side. So if we integrate both sides, so let us see what happens when we integrate both sides. So integrating both sides. Okay, so guys, let us go ahead and integrate both sides. On the left hand side, of course, we are integrating with respect to dx. So on the left hand side, obviously there's a derivative, and then we are trying to integrate it, which means we are trying to evaluate the antiderivative. Guys, we know derivative and antiderivative are the reverse of each other, so they are going to cross out. Basically, they're just going to cross out each other. So on the left hand side, when I apply the integral, I'm only going to be left with the product u times v, because the derivative and the integral is kind of going to cross out. Okay, it is not exactly crossing out, but there's things happening behind the scene, but we know informally that they are the reverse processes, so they undo each other. Okay, so that is the left hand side. Guys, on the right hand side, well, we just have to rewrite stuff. We cannot really cross out anything, so it's going to be integral. So guys, I'm just applying integration on both sides. So integral of u times dv over dx, right, with respect to dx. Don't forget that dx, and then there's a plus integral, and the next term would be, I'm just going to rearrange this a little bit. So can I write this as, or maybe we can let us leave it like this for now, du over dx and times v, and then of course there's going to be another dx, because we're integrating, we always integrate with respect to something, and in this case it's going to be with respect to dx. Okay, so guys, from here, so what I'm going to do is, from here we are going to solve for this. So if I want to solve for this, that means it's going to look like this, u times dv over dx, and then still there's a dx here, Let me put it in the parentheses. And then if I'm solving for this, then uv will stay like this. And then I have to bring it to the other side. So it will be minus integral of this whole thing, du over dx times v. Let me put it in the parentheses as well. And then there's a dx. Okay. So guys, first we started with the product because that is what motivates this integration by parts. We then took the derivative of the product, and we know the derivative for the product, how we write it out into two pieces. Then what we did was we integrated both sides. Why we are integrating? Because we want to find the formula for integration by parts. So it is obvious that we should try to integrate both sides. When we integrate both sides, guys, on the right hand side, all we have to do is we just have to apply the integral and just write it out. But on the left hand side, we can see that there's a derivative and an antiderivative. They undo each other, which that is exactly what they did. I was left with this. And then from here, now it's more about just manipulating and just trying to like see what we can do to actually make it look like as the integration of parts formula. Okay. So we try to solve for this expression right here. Once we have it in this form, guys, some people also like to think of this as the formula for integration by parts, or they like do one more step to get it into some other form. And in your textbooks, most of the times you will either see this or there's one other step that people like to take and then get it into another form. Guys, if you are using that form or that formula that is in your textbooks and you have been working with it, guys, that is fine. If that is working for you, just keep using that. But here I'm going to show you something different that I learned when I was a student of calculus. Okay, so I'm going to show you that formula. Then you can compare my formula with what you usually see in your textbooks, and then you decide for yourselves which one you like more. Okay, if you still like the one in the textbook and you are confident and you have been using it, guys, keep doing it. But I mean, I'm going to show you my way, and then you guys decide which way you want to use. Okay, so guys, what I like to do from here is I like to do some substitution. I like to call this u as a function f of x. Okay, and I also like to call this dv over dx. dv over dx, I would like to call it as a function g of x. Okay. All I'm doing it to get me a integration by parts formula, which is convenient, which is easier for me to use. Okay, that's why I'm doing these substitutions. So if I do these substitutions and I substitute back in this form, let us see what we have. So guys, I need more space. As you probably already know, if you have been watching my videos, I do not have a big board here, so I got to make the best of what I have. So let us see if I can make more space. To make more space, guys, I may have to get rid of some of the things. So I'm sure if you are taking notes, you can, I mean, this is already, you already saw all that. So let us try to go back and revisit this. So I'm going to get rid of these pieces and then see if we can squeeze everything in this space. Okay. Let me also get rid of the integration by parts so that I have more space to kind of squeeze in everything. Okay. So guys, from here we are substituting back in here. So let's see what happens. So we get on the left hand side, u is f of x now. We can just leave it as f, okay? And then dv over dx is just g. So it is f times g. And that is what I would have liked in the first place. Integration by parts, like when I have the product of two functions, I just want a direct formula for it, okay? So let us see what happens on the right hand side. Guys, on the right hand side, I have u times v. U is simply f times v. Okay, here's the thing, guys. I have a derivative dv over dx, which is gx. From this, if I have to just evaluate the evaluate v, then we already know that to evaluate v, we have to apply the antiderivative or integral on both sides because they undo each other. So to undo the derivative piece, to get v by itself, I have to take the antiderivative or I have to apply the integration on both sides. So when I do that, then I get v equals to integral of gx dx. Okay, yeah, that's pretty basic concept that I expect you guys to already know. So instead of v here, I got to replace that by integral of, so f times integral of gx. I don't have to write x here. It's understood that it is a function of x. That takes care of this uv. guys, then minus integral, guys, let us look at this carefully. Du over dx, I already have u equals to fx. So to get du over dx, it simply means that I have to take the derivative of this function, and the derivative of this function I can write just f prime or df over dx. It's up to you. Just to save some space, I'm just using primes. Okay, we know primes and d over dx both represent derivatives. Guys, that takes care of this piece. Again, it has to be multiplied by v, but we already know that v is in terms of the function, or in terms of function g, is integral of g of x dx. So I have to replace that v by integral of g of x dx, right? That's what it is. And then don't forget there's a dx all the way at the end. Guys, that is what I like to call as integration by parts formula. And this is a formula that I have been talking about, like, which is slightly different, which looks slightly different than what you would usually see in your textbooks. And guys, I'm going to show you these examples where I directly use this form rather than the form that you see in your textbooks. Finally, you decide which one you want to use. So let us try to understand this a little bit. So what does it say? It says when I'm trying to find the integral of a product of two functions, f times g is basically product of two functions. What does this equal to? It equals to, there's the first function, right? You don't do anything with that first function. We are not finding the derivative. We're not integrating it. It is just rewriting the first function times the integral of the second function. So it's the first function times integral of the second function minus, okay, then integral of product of the derivative of the first function f prime times the integral of the second function with respect to dx. That is what it basically says. Okay, I mean, I'm not trying to say that it's a very simple formula, but writing it in this form makes it a little easier for me to evaluate these integrals where one has to use the integration by parts method. Okay, so guys, I want you to actually write this formula somewhere, preserve it. I mean, you can find it on the internet as well. When I learned calculus and when I learned this integration by parts method, this is the formula that we learned, and I sticked with it, although I was able to see the other form as well, but I always liked this. This helped me to get the job done quickly, and I mean, I got used to this one. So I wanted to share this particular one with you. You can already find that other one in your textbooks. Guys, now there's one other important thing that one has to know before we actually start doing these examples. That is, when you have product of two functions, then one has to decide which function you want to treat as the first function f and which one as the other function. So there is like a trick technique for that. So I'm just going to share that technique with you, and then again, once we start doing examples, you will see that we'll be actually using that technique. So what the technique is, guys, when we are evaluating this, we got to give preference to certain functions before the other functions. So it is not too complicated. What I like to call it is as the short form for that, I like to think of that as an I-late, I-L-A-T-E. So what does that mean? So my first choice for f should be starting with I, and I here stands for the inverse function. So if you have, I'll tell you what that really means. Inverse function. So for example, if I have to do the integral of, let us say I have an x squared and then I have a sine inverse x, okay? Then what I should do is, based on this trick, what I should do is I should not use this as my function f and this my g. Rather, what I should do is I should rearrange and I should use sine inverse x as my f and this as my g. And that's how we'll be able to actually evaluate the integral. If we do not use the right f and right g, guys, either we will have to do so many more steps, or we may not be actually able to evaluate the integral by using the integration by parts method, okay? And that you will see when we start solving examples. So guys, that is what I mean by this short form. So first you give preference to inverse functions as the first function as an f function. Then the second comes the L, which is the log functions, okay? Then obviously third, you may have already figured this out. The third one is the algebraic functions. algebraic functions. Then we have the fourth one is the T stands for the trig functions. So algebraic functions come before trig functions, and the last one is the E, which stands for the exponential functions. So I think we almost covered all the functions. The most popular ones that we most of the times we see are the logs or algebraic and trig and exponential functions. Again, sometimes you may also have an inverse function, so you know what, like, give that the first preference, and then it goes this way. Okay, so guys, that is all I want to tell you about the integration by parts formula. So we kind of derived it, and finally we have it in this form, which again is slightly different than what you will see on your textbooks, but it is not different. It is just the same thing, but written out in a slightly different way. And I like to think of this as like written out in a more user-friendlier way. Okay. So guys, I'm going to stop here, and then I will see you in the next video with examples on using the integration by parts method, and then we are going to follow this as well, and make sure that we choose the right F and right G, because that is